Okay, in this video I'm going to show how to create a perforated surface in Grasshopper with this kind of fading effect that we see here. I'm going to start with a single surface. The only requirement is that it needs to be planar. And I'm going to input this one into Grasshopper to begin with. I usually like to work with this one on, so then I just see what I touch here. Okay, I'm going to create some surface frames here. And if I input a point component here from the alpha frames, I can kind of get points inside the surface. I can control the amount of points by adding a slider here. Okay, that will give us around 1,000 points. Maybe to work with, I'll just leave this number lower. Before, actually, I don't want to have these points in the edges of the surface, so I'm just gonna make a quick offset of that surface to avoid that. I'm gonna get the wireframes, so the curves of the surface. I'm gonna join those curves and then offset curve. Just like just a bit, so I don't get so I don't get points on that edge of that surface. I'm gonna get another boundary curve from this one. Boundary surface, sorry. And now this one is the one that I will create frames out of. Okay, so here are the points that I will begin using. And a simple thing that we can do is to place circles on these points. And you will see here if we do this, they're kind of in the incorrect plane. So I need to evaluate to get the frames of all of these. And actually I can just get them from here. So if I do that, they're in the correct plane. Okay. Then I can just input some sort of slider for the radius of the circles. Okay. So there I have that. So now I want to work on creating that. Okay, let's just try something simple maybe first, which is that you can always relate the radius of these circles based on the distance they have to a point. So let's input that point here. And then let's measure the distance that these points have towards this one. And then we can use that as a way to define the radius. Of course, we can just flatten this one here and then flatten this one here. And this value is too large, but we can just change that by dividing that number into something. We need a larger number here, apparently. Oops. Here we go. And we can also kind of map these. Another thing that we can do to get more precise control of the radius. You see how now these ones, the ones that are closer are smaller, the ones that are further away are larger. But if you want to have like precise control over the radius of these circles, let's say you can only do the largest circle can only be like, I don't know, 5 centimeters, and the smallest circle can only be 1 centimeter. So there's a way that we can do that. And we can use a component called remap numbers to do that. So we will first get kind of the domain of these. So this would be the source domain, and then we can construct the construct domain. That will be the target domain, and the values that we will map are these ones. So let's say we want to have just numbers between 0.05. Let's see if these numbers make sense or not. Okay, so these are the map numbers, and you see here, right, like you can have precise control over how big is the biggest circle and how small is the smaller circle. Oops. And then these ones get adjusted that way. Oops. Okay. Okay, but now let's try doing what I wanted to show you, which is how to do something like this. So what we need to do is that I'm just gonna group this here and put it away, so then we can work on something else. So I want to get the C values of these ones, because as you can see here, the fading is done in the C direction. So I'm gonna just get the C values here. And what I want to do, I'm just gonna flatten this list. What I want to do is I want to, according to your C value, I'm gonna take away some of these points or not. So what I can do is I can use a larger than component connected to a jitter component. This one basically reshuffles a list of items. So I'm just gonna work on this, and then I will try to explain a bit more. I'm gonna get a bounce here just to see what is the C value, the lowest one to the largest one. I'm gonna use a deconstruct domain and a construct domain component, and I'm going to, so the start is 0.3, and I'm going to add something to that start. I'm gonna add a value to control the fade out that occurs in the bottom. And I am going to subtract a value. I'm gonna call this bottom, and then I'm going to subtract a value to control what happens in the top. So the top is this one here. So now I have a new domain. I can use this range component to create a list of numbers based on this domain, and how many will be the list length here. That will give us a total number in the list. So we have 1,472 points. So now what this one did is created a list of values based on that range that I just gave it, from the lowest, the smallest C value to the top C value. So now I can use this jitter component that will basically shuffle this list. And I think this just needs like a number 1 slider here to do a complete shuffle, and then you can just add another slider here to reshuffle things. And then this jitter component creates a list of numbers based, this jitter component shuffles these list of numbers. So now I can compare them. If number to test is this one. No. Number to test. No. This one is the one that I want to shuffle, I think. And then this one is the one that I want to test, I think. Yep. And now I get a list of true and false. The ones at the end, okay, will almost unlikely be false because I think these are the ones at the top, and the ones at the bottoms will almost all likely be true, I think. Okay, let's try that. And then this is the list that I want to affect. Yes, okay, that was it. So basically, this one allows me to shuffle this range, so then I can compare it to the original list with the z values. And so the probabilities of the higher ones to be more than the z value of here, it's really high, so that's why we have more here. And then the probability of the lower portion to be larger than the number we shuffled with, it's really low, so that's why we have less points here and more points here. And then what I did here is to control, I'm just gonna put the minimum here to 0 so that you understand. And then this one too. This one allows me to kind of take away some of those numbers from the equation. So if I don't have anything here, then all of them can be affected. Let's say there can be a situation where the top row is also affected, but if I always want to have like a clean top row, you see the second row has one missing there, so then I just can increase this slider to make sure that there's no way that that this top part will not be affected. So the more I slide this in, the more I have like a full rows here that are not affected. And the same with the bottom here. If you want to have like a more disappearance in the bottom, you can just increase this one here. So basically this one controls the bottom and then this one controls the top. Okay, so now that I have that lists done, I can just create circles out of them. But now that I think about it, it is this frames that I want to get rid of. I want to, use this cold pattern for, but then I will just flatten this one. And then I can use these ones to make the circles. I will just use the same radius for now. I'll just use a slider. Okay, this one here, a same number for all of them, and then this is the list. Okay, yep, there it is. So now, of course, all the circles have the same radius, but of course you can also use this list that basically is using the distance to this point also. Okay, no. I also need to, if I'm gonna do that, I also need to do this, I think. Yes. Okay. So I needed to also use the cool pattern for these map numbers if I wanted to do that. But you can just use a single value also for all of the circles, no problem. Okay, and then you can, now that this is done, I can actually make the perforations. So I'm gonna just, something that I like to do is place a data dump here, because so then when I'm working on modifying the definition, this doesn't get recalculated for the surface split, which because imagine you have like so many different circles here, like near 1,000 circles, so then every time this one runs, it really makes it slow. So this will control the flow of data here. Okay, where's my surface? Here, this one. And then usually the first item is the big surface. I said usually. Or usually it's the first or the last one. Let's see if it's not the last one. I can show you how to also grab it parametrically. Okay, yeah, that's the one. Oh wait, that's not the surface I wanted to split. It's this one, the original one. Okay, maybe in this case it's the first item. Okay, yeah, that's it. And of course you can now that you have this parametric definition, you can adjust things like such as having more or less numbers. Here you can increase the number of circles here by just going back here and then increasing this number or this number also, and so on. And every time this is why I put the data dump here, so it doesn't need to recalculate every time I'm changing some of the definitions here. And then you just bake that, and now you have your perforated surface. And that's it. Oh, that was a bad idea. I kind of asked it to bake everything. Okay, but now you have it.